Hi and welcome to this answer video from Classroom Secrets. In this video, I will walk you through the answers to the questions on the worksheet Equivalent Fractions 1, as well as talking you through some of the trickier parts to do with this skill. For question 1, we have been asked to identify the pairs of fractions that are equivalent to each other. So for A, first of all, I have started by finding out what fraction of each rectangle is shaded. Here we know 2/8 has been shaded because 2 of the parts are shaded out of a possible 1, 2, 3, 4, 5, 6, 7, 8 equal parts. Moving on to the second rectangle, this has been divided into 4 equal parts, therefore our denominator is 4 and only one part has been shaded, so our numerator is 1. To see whether they are equivalent, we can look at the denominators. 8 divided by 2 equals 4. We must do the same to the numerator. 2 divided by 2 equals 1. So these two rectangles do show equivalent fractions. So A should be circled. B says 1/6 equals 6/12. Well, if I look at the denominators, I know that 6 times 2 equals 12, so I must do the same to the numerator. However, 1 times 2 does not equal 6, so B is not an example of equivalent fractions. C, I have 2 more shapes to compare. Here I can see that 1 out of 3 parts has been shaded in this circle, and in this circle 1 out of 1, 2, 3, 4, 5, 6 has been shaded. I know that 3 times 2 equals 6. If I do the same up here, 1 times 2 does not equal 1, so these are not examples of equivalent fractions. D says that 1/5 is equal to the shaded parts in this circle. To find out the shaded fraction, I count how many parts have been shaded. In this case, 1, 2. So this is my numerator, out of a possible 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I know this circle is showing 2/10, the shaded part. And I can see that 5 times 2 equals 10. So I must do the same to the numerator. 1 times 2 equals 2. So these are examples of equivalent fractions. So this should be circled too. Therefore, A and D should both be circled. Question 2 asks us to match the fractions to their equivalents. Looking at this rectangle, I can see that it has been divided into 3 equal parts, and only one of these parts has been shaded. Therefore, the fraction of the shaded part of the rectangle is 1/3, and I need to find an equivalent fraction to 1/3 out of these 3 fractions above. Looking at 1/6, I can tell that it is also a unit fraction, just like 1/3, because they both have a numerator, or top number, of 1. Their denominators are different though, and this tells me that they cannot be equivalent fractions, because 1/6 has more parts than 1/3, so its parts will be much smaller than the parts in 1/3. So moving on to 2/6, which involves completely different digits, I'm going to see if there's a pattern that links the numerators and denominators. And using my knowledge of the 2 times table, I know that 1 times 2 is 2, and 3 times 2 equals 6. Therefore, these 2 fractions are equivalent. I'm going to check 2/9 just to make sure. So starting again with 1/3, and I want to see if I can find a common link between the numerators and the denominators. I know that 3 times 3 equals 9, so I must use the 3 times table with the numerators. 1 times 3 does not equal 2. Therefore, these 2 fractions are not equivalent. This tells me that my answer is 2/6, so I can write this here, and I can also match the rectangle to 2/6. Moving on to B, this time I have been given 1/8, and I can see my first possible fraction here is 1/2. Again, these are both examples of unit fractions. They have different denominators, and this tells me that they cannot be equivalent fractions because 1/8 has many more parts than 1/2. Therefore, 1/8's parts will be much smaller than the parts in 1/2. Moving on to 2/10, I'm going to write this one out and investigate to see if there is a common pattern. For example, if I multiply 1 by 2, I get 2. If I multiply the denominator by 2, 8 times 2 does not equal 10. So these two are not equivalent fractions. I'm going to check this last fraction now. So 1/8 equals 2/16. I know that 1 times 2 is 2. I must use the same times table. 8 times 2 does equal 16. So these two fractions are equivalent. Therefore, this must be my answer. So I can now write 2/16 up at the top, and if I like, I could even draw a line to match these two together. For question 3, Hanaya says, all these fractions are equivalent to 1/6. Is she correct? Explain your answer. So I'm going to write 1/6 to begin with. And starting with A, I can see that 2 parts have been shaded in the circle, and altogether there are 6 equal parts. Now, just looking at these two fractions, they both have 6 as a denominator, and they both have different numerators. Now, I know that 2/6 is more than 1/6. It's actually double 1/6. Therefore, these two fractions are not equivalent because 2/6 is greater than 1/6. Starting with 1/6 again, moving on to B now, I am going to find out whether it is equivalent to 2/12. I know using my 2 times table that 1 times 2 is 2, so I must use the same times table. 6 times 2 is 12. Therefore, these two fractions are equivalent. If I look at this fraction, I can see that 2 parts have been shaded out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Therefore, B and C show the same fraction. B shows it in number form, while C shows it in a rectangle. So I could tell straight away that 1/6 equals 2/12, and they are equivalent. Moving on to D, our final fraction, 1/6 equals 4/6. Again, these two fractions have the same denominator. This one has 1 as its numerator, this one has 4 as its numerator. Therefore, 4/6 will always be greater than 1/6. So these two fractions cannot be equivalent. Just to finish off the question then, Hanaya's statement is incorrect because only B and C show equivalent fractions to 1/6. That was an answer video from Classroom Secrets on Equivalent Fractions 1. I hope you found it useful. Remember, You can access the linked video tutorial over on kids.classroomsecrets.co.uk, or you can find many resources on equivalent fractions over on classroomsecrets.co.uk.